Hello class, welcome back to our YouTube channel, and for today's class we are going to discuss about our lesson is lesson 4, which is the variance and standard deviation of discrete random variables. So from our previous lessons we had the mean of the discrete random variables. This time we are going to discuss the variance and standard deviation. Now let us have our discussions objectives. First, the learner will be able to illustrate the variance and standard deviation of a discrete random variable, calculate the variance and standard deviation of a discrete random variable, interpret the variance and standard deviation of a discrete random variable, and lastly, solve problems involving the two variance and standard deviation of probability distributions or our discrete random variable. Now, before we proceed with the main topic, let's define frequency. So, what do we mean by frequency? The frequency of an event is the number of times, or it's denoted as small n, the number of times of observation occurred or recorded in an experiment or a study. So this is somehow the total outcome, the total times or the total number wherein our outcomes or the possible values in our variable happen. So it is the number of observation, times of observation. So with regards to frequency, we have the so-called frequency distribution. So previously we discussed probability distribution, but what is the difference with frequency distribution? So we have the number of times observed. Unlike in probability distribution, we have the random variable values and then its corresponding probability. But this time, the frequency distribution is an overview of all distinct possible values in a variable and the number of times they occur or we observe that outcomes or that values happened or occurred. So let's have our examples here. Example of the data, we have the scores of 20 students in an exam. So we have 6, 9, 10, 10, 9, 6, 7, 7, 10, 9, 7, 10, 6, 10, 9, 7, 4, 10, 7, and 10. So we have 20 scores. The scores of the 20 students. So how can we put it in a frequency distribution? So the frequency distribution will show all the distinct values or all the outcomes distinctly in this data or this variable and how many times they occur. So let's have the table for our frequency distribution. So in this example, we'll have this frequency distribution. So this shows our score. So how many numbers or how many scores we have. So distinct scores we have are 4, 6, 7, 9, and 10. So for you to be able to easily determine the distinct values, you need to arrange it either in ascending or descending order. So you group those numbers or those scores, those values that are the same, and you count the number of times it happened, or we observed that value. So this time, the frequency is the number of students who got the same score. So the score of 4, there are only one student who got 4 in an exam. 6, for the score of 6, we have 3 students who got 6, 5 students who got 7, 4 students who got 9, and 7 students who got 10. So this is the frequency distribution for this data of scores for 20 students in an exam. So now, we are going to get the variance of the frequency distribution. So why are we going to get the variance of the frequency distribution? But our topic is about the probability, the variance, and standard deviation of the discrete. So we are going to compare how can we get or compute or solve the variance in frequency distribution and in probability distributions for the discrete random variable. So for the frequency distribution, we can compute the variance with these following steps. So first, compute the mean by using the formula. So when we have number of samples or the frequency for a specific number, we can use this formula. So the mean, or x bar sample, this is sample mean, is equals to summation of your frequency multiplied by your x all over to the number of your values or the number of your outcomes. Next, subtract the mean from each score. So we have the mean, and then we have each score. Then you need to get the square of the result, the square of the difference. Next, multiply the result by the corresponding frequency, and we need to add it to our columns, so to the columns of the frequency distribution. And lastly, we can now compute the variance using the formula, this one. So we have summation of your frequency multiplied by the difference, square of the difference of the mean and the value or the score all over the total number of your data. So let's apply these following steps. With this example. So our example problem, we had to our frequency distribution, compute the variance of this frequency distribution. So this is the frequency distribution we had earlier. So we have score 4, 6, 7, 9, and 10, and the frequency we have 1, 3, 5, 4, and 7. So first step, we need to compute the mean. So how can we compute the mean? So compute the mean by using the formula of this one, x bar equals to summation of your f, the score multiplied by the score, the product, you get the sum of products all over n. So first, let us have the frequency distribution. And what is the product? So we have here f times x, so frequency times the score. So what is the product of 4 times 1? We have 4. 6 times 3 we have equals to 18. The product of 7 times 5 we have 35. 9 times 4 we have 36. And lastly, 10 multiplied by 7 we have equals to 70. So this time we need to get the values, which is the sum of the products. So we get the sum of these products we have 4 plus 18 plus 35 plus 36 plus 70. That is equals to 163. And for this, for our n, we need to get the sum or the total number of our students or the total number of the data. So we have equals to 20. So we just input or substitute the values for our formula. Then we have the mean equals to 163 over 20. That is equals to 8.5. So this is our mean for this frequency, given frequency distribution. Now, second step. For the second step, in our solution, we need to subtract the mean from each score. So we already have the mean, which is 8.15. Then after we subtract it, we need to square the results, square the difference. So we have the probability distribution and the product of our frequency and the score. So now we need to get the difference of x, or 4 minus 8.15. So we have equals to negative 4.15. Next, we have 6 minus 18, rather 8.5, which is our mean. That is equals to negative 2.15. And we have 7, the score of 7 minus 8.15. We have equals to negative 1.15. And for fourth score, we have 9 minus 8.15. We have equals to 0.85. And lastly, we have 10 minus 8.15. That is equals to 1.85. So it says here that we need to square the results. So these values, we need to get the square or multiply it to itself, or let's say negative 4.5 multiplied by negative 4.15 multiplied by negative 4.15. So the answer is 17.2225. So that is the square of negative 4.15. Next, we have negative 2.15 squared. That is equals to 4.6225. Negative 1.15 squared, we have equals to 1.3225. 0.85 squared, we have 0.7225. And lastly, 1.85 squared, we have 3.4225. So this is our second step rather. Now, let's have the third step for our solution in getting the variance of the frequency distribution. So we have to multiply the result that we have, which is the square of the difference, by the corresponding frequency for that row. Then we need to add the result in the succeeding column. So we have these tables from our previous steps already. Now we need to multiply our frequency. So this second column to our fifth column. So the square of the difference. So we have 1 multiplied by 7.2225. We have equals to 17.2225. So anything that we multiply to 1 will be identical also. So we have 3 times 4.6225. That is equals to 13.8675. Now, 5 multiplied by 1.3225, that is equals to 6.3225. 0.6125. Then 4 multiplied by 0.7225, that is equals to 2.89. And lastly, 7 multiplied by 3.4225, that is equals to 23.9575. So, this is our sixth column. Resolve to the product of the frequency and to the square of the difference of your score and mean. Now, let's have the sum of the products. So we have to get the sum of this column. So you just add 17.2225 plus 13.8675, 6.6125 plus 2.89 plus 23.9575, that is equals to 64.55. So this is the sum of our products. And for the last step in this solution, we can now compute the variance using the formula. So square. So this is the notation to our variance. So we have the theta square. This is equals to the summation of the products of the frequency and the difference square to the difference of your score and mean all over n. So we just substitute the values we already have from our previous steps. So we have 64.55 for the sum of products all over 20. So that is the total number of data. So the total number of students we have for the with scores in an exam. That 64.55 all over or divided by 20, that is equals to 3.2275. So this is the variance of the frequency distribution, or in the example we have the frequency distribution for the scores of the 20 students.